You have probably heard of time machines which allow you to travel in time. Usually you are just living today and you remember yesterday or a few years before, depending on how old you are, and you kind of want to think about what is tomorrow and so on. But the time machine is supposed to allow you to go back in time and boom, go back forward in time and change the past, change the future, all those exciting things if you saw some nice movie and so on. But ice cores are like time machines, except they only allow us to go back in time. How do they do that? Here are some brave scientists who are out there on Antarctica or Greenland. You can find out these where they are from the web, but it doesn't matter. So Glacier. Now comes the glacier part. Already we said once that snowfalls, let's say on Antarctica or Greenland or the Himalaya, and more snow falls next year because it's too cold and the snow that has fallen doesn't melt, and it keeps on falling for years and years and years and millions of years sometimes. Okay, and it keeps getting compressed because snow gets heavier on top, and eventually gets so compressed that under pressure it begins to look like ice, and it's called a glacier as opposed to ice, because ice you get by freezing the water. Snow is not completely frozen. Of course it is low temperature water, but when it gets compressed and under pressure and temperature, it becomes ice-like. What is the difference? Glacier is like honey or molasses. It can flow. So if it is forming on Himalaya and there is a slope, then glacier can flow down. We'll see photos later on, but here we'll just remember that glacier can not only begin to build for a few years but lots of years, and it can get thicker and thicker. And in fact, glaciers on Greenland and Antarctica are several kilometers thick. Now you imagine water that's several kilometers high to go deep into the ocean. How much weight is there when you put ice like that? It's so heavy that land gets pushed under it. So you can imagine so much loading on the land, and the top continental crust, if you know the geology, land is actually sitting on something that is not very solid, so it can push down. It's like push your hand into the skin. It can go in because unless you hit the bone, there is some flesh, you can push it. So ice is pushing down on the continent. So people go there, they use a drill, they drill into the glacier, and then they bring out the core. It's called the ice core, and you can see slight change in color, and if we look at the details with a microscope, you will see that there are bubbles trapped in it, there are dust particles trapped in it, there are pollen from trees and flowers trapped in it, and so on and so forth, and some zooplankton are often trapped in them as well. So as snow falls, it is capturing the bubbles of the air at the time. More snow falls on top, more snow falls on top, so each year some information is getting trapped into the snow, and it is becoming buried into the ice core. So if we carefully take this, put it in a freezer somewhere so it doesn't melt away. So if you're an Indian, there is a laboratory, government lab called National Center for Polar Ocean and Atmosphere Research, I think, or National Center for Polar Ocean Research, where they have a core lab. To go inside, you have to wear the kind of clothes these people are wearing, because it is so cold in that lab. It is so cold because the cores cannot be allowed to melt. Okay, exciting science. So you can go and extract carefully the bubbles and know at what time that bubble formed, because if you start at the top, that will be, let's say, this year. As you keep going deeper and deeper, you can count the number of layers that are there and derive the time as you go down. So this is the top, they are going deeper and deeper. Sorry, this is the bottom here. So this is the more recent ice. You can see it's not completely compressed yet, it is lighter, this is darker. So you can start at the top and start counting years, and when you know the year, you take the bubble there and see what amount of CO2 is there, methane is there, N2O is there, and you know that at that time that was the amount of CO2 in the atmosphere or methane. You can also derive temperatures using other types of isotopes in the water. You think of water, if you know enough chemistry, as H2O, but H is not just H, it can have deuterium, so it can have 2 protons or instead of just 1. So oxygen also has oxygen 16, 17, 18. If you don't know, don't worry about it, the older ones may understand. So based on temperature, various signatures, chemical signatures, isotopic signatures are sequestered or buried or saved in the ice cores. Amazing detective work can be done. You can see some details here. Antarctic events that changed the world. So you're starting here at the top. So you have 2020, and this is counting kind of actions that have happened here. It says 44 nations engaged in Antarctic science as a member of SCAR, that is the international organization that is organizing these. In 2016, carbon dioxide concentrations in Antarctica reached 440 ppm, nearly 1.5 times greater than the pre-industrial levels of 278 that we talked about, and so on. Down here you have 1750. Carbon dioxide concentration shows first increase due to land use change, which means we were converting forests to farmlands. So that is the time series we saw. Here we are, the bottom of this ice core that we are looking at, and we measured the concentration of CO2 from this ice core. What a nice detective work. This is why you call it the time machine. You can go back in time using this ice core. Richard Alley, Alley is the name, Richard, Richard, has spent a lot of years, many decades, working on ice and glaciers, and he's an expert on this, and he calls it the 2-mile time machine. When he wrote it, there was a 2-mile long ice core that was drilled, and next podcast we'll come back and look at some of the signals buried in this long ice core, and we'll see how far back we can go in this time machine, and you will be amazed. It is truly amazing. Hopefully it'll make you get excited about learning biology, learning about glaciers, learning about experiments, learning about chemistry and so on, so that you can also become a detective and go back in time with ice cores and visit exciting places like Greenland and Antarctica and so on and so forth, and the Himalaya mountains, Andes, and so on as well. Okay, so we'll come back and look at some of the data derived from these ice cores and see just how amazing it is and how much information is buried in these ice cores. There are many other such signals buried. If you have been into a cave, for example, they have stalactites, they have stalagmites, which are also depositions of water and chemistry, which are burying signals of past climates, past CO2 levels. If you go to a coral, if you know what a coral is, grows in the water in the ocean. If you don't know, don't worry, or you can look it up on the web. Corals also have signatures of past climates in them. If you look at a tree is growing, its trunk is getting thicker and thicker. Each year its trunk gets thicker, it puts a ring. So there are things called tree rings, which are also catching signals of rainfall and temperature and CO2 levels and so on and so forth. So we'll look at this later on in the next chapter. But remember, we are here talking about carbon cycle, so we want to understand how ice cores are used to derive past greenhouse gases, not just CO2, also methane and nitrous oxide, and there are also ways to derive past rainfall and so on and so forth. So we'll come back and look at CO2 data again, but this time from the ice core, and we'll see how far back the measurements have gone, how far back people have gone in this ice core time machine. Okay, so we'll do that in the next podcast then.